continuing our conversation on equations quadratic in form, I will let you try to do number 3, but I will give you a heads up. You should check your solutions. Here at the end, when you get the x equals, make sure you go back and check your solutions into the equation. Taking a look at a different type of problem, here we have 2x to the 2/3 minus 9x to the 1/3 plus 4 equals 0. And for this problem, we notice that my middle term, x to the 1/3, compared to the first term, x to the 2/3, the first term's exponent is twice the second term's exponent. 2/3 is equal to 2 times 1/3. We have the conditions so that we can start rewriting this using substitution. We'll start out determining what u should equal, and as we've said before, we're going to take u to be the middle term, the middle term's variable part. So u equals 1/3. That means if I square both sides, 1/3 squared, u squared would give me x 1/3 times 2, x to the 2/3. And notice it matches my first term's variable part. Now I can rewrite the substitution. Coefficients will stay the same. 2u squared, x to the 2/3, minus 9u plus 4 equals 0. And I can start to solve for u. I have a trinomial. I need to find two numbers that multiply to be 8 and add to be -9. And those two numbers should be -8 and -1. -8 plus -1 is -9. -8 times -1 is +8. And I can split that middle term, 9u, -9u, 2u squared minus 8u minus u plus 4 equals 0. Now before I go too far into this, I went to factoring because I kind of already knew that it would work out. Two numbers that multiply to be 8 and add to be -9. But if you didn't, and you did not see that factoring pattern right away, if the factoring pattern was not evident, you are more than welcome to go ahead and apply that quadratic formula. A is 2, B is -9, C is 4. Since I'm doing factoring with this one, I'll go ahead and finish it. Factoring out the first two terms, 2u, u minus 4. Sign in the middle comes down. I keep that negative sign. U and 4 have nothing in common, so I'm going to factor out a 1, but I'm really factoring out a -1. U, I have a +4, but I'm factoring out a negative. I need a -4, and I notice that u minus 4 now is my common factor. I can pull that out. And then 2u minus 1 for that reverse distribution property. And I can solve for u. U minus 4 equals 0, so u equals 4. 2u minus 1 equals 0. 2u equals 1. U is 1/2. I have two solutions for my quadratic equation that is the substitution. I need to now reverse the substitution and then check my answers. I do not have a polynomial to start with, so I don't know how many answers I have. Let's reverse the substitution. U was x to the 1/3, so u equals 4 becomes x to the 1/3 equals 4. In order to get rid of the 1/3, I can cube both sides, raise it to the 3rd power, and x equals 4 times 4 times 4, which is 64. Similarly for 1/2, u is 1/2, x to the 1/3 will give me 1/2, cube both sides, x is 1/8, 1/2 times 1/2 times 1/2. And I have two potential solutions. I need to check them. Since I have a lot of room here, I'm going to use this room. 2 times 64 to the 2/3 minus 9 times 64 to the 1/3 plus 4. Does that equal 0? 64 to the 2/3. I'm looking at cube root of 64 squared. So I can rewrite the rational exponents as radical expressions. Cube root of 64 is 4. 4 squared is 16, and 16 times 2 is 32. 9 times 4 is 36. And I see that I have 32 plus 4 will give me 36. Minus 36 does indeed give me 0. 64 checks out. I can check 1/8. I'll do it right here to the side. 2 times 1/8 to the 2/3 minus 9 times 1/8 to the 1/3 plus 4 equals 0, question mark. And I can rewrite exactly like I did before. Cube root 1/8 squared, cube root 1/8. The cube root of 1/8 is 1/2. 2 times 1/2 squared, 9 times 1/2. 1/2 squared is 1/4. 2 times 1/4, we can write that as 1/2 minus 9/2 plus 4 I can write as 8/2. 8 divided by 2 is 4. And I see that I have 1/2 and 8/2. That's going to give me 9/2 minus 9/2 equal to 0. Yes, 1/8 works as well. Ultimately meaning for problem number 4, we have our solution of 64 and 1/8. One more different type of an example. 30 over x squared minus 1 over x minus 1 equals 0. If I look at the variable parts, I notice the exponent in the first term is double that of the exponent in the second term. We could also rewrite this equation. Instead of using rational expressions, we could change them to negative exponents. And I'm doing this for 2 reasons for you right now. The first reason, you could have an equation with negative exponents in it. What does that really mean? Well, negative exponents means that I have rational expressions. The negative exponent is on the wrong side of the fraction bar, and we need to move it. Also, this really highlights the exponents. Like I said before, the exponent for x in the first term is twice that of the exponent for x in the second term. I have that same condition that we've seen in all of the previous problems. So, let's start out with a substitution. Depending on the situation that you have and how you want to work with u, you could let u be 1 over x, or you could let u be x to the minus 1. They are equivalent. It just depends on, do you want to make sure you're keeping up with negative exponents, or do you want to make those rational expressions highlighted? Whatever I do, u squared will be 1 over x squared, or x to the minus 2 power, x to the negative 2 power. No matter the substitution that we use, whether it's with the rationals or with the negative exponents, we will end up with the same substitution equation in u. 30u squared minus u minus 1 equals 0. No matter which one we use, we'll get that same equation. Let's work on solving it. I'm going to use the quadratic formula since I haven't used it in this lesson. I have it written in descending powers of x, so a will be 30, b will be negative 1, and c will be negative 1, just pulling from the different coefficients. A goes with the squared variable, b goes with a single variable, and c is the constant. And u, because I'm solving for u this time, I want to put u there, not x. Negative b plus or minus square root b squared minus 4ac all over 2a. And I'm going to do a tiny little bit of computer magic and increase my size on this so it's a little bit easier to see. And we can plug in our numbers. B is negative 1, so we'll plop the negative 1 in there. A is 30. and c is -1. And I'm going to make sure that that radical is extended all the way. And now we can start simplifying. U equals minus -1 gives me a +1. -1 squared is +1. 4 times 30 is 120. I have two negatives here, -4 and -1, so I'll get a plus 120 under the radical. And 2 times 30 is 60. U equals 1 plus or minus square root 121 over 60. Square root of 121 is 11. And this is leading me to believe that we can factor this actually in the very beginning. It is factorable because we get a nice perfect square under that radical. Two answers. 1 plus 11 over 60. 12 over 60 will give us 1/5 or 0.2. And then 1 minus 11 over 60, 10 over 60, which is 1/6, or a repeated decimal answer. And so we have two answers for you, 1/5 and 1/6. I'm going to leave them as fractions. I think it's a little bit easier working with fractions than working with the decimals, especially with that repeated decimal and with 1 over 6. So let's come back up here to now. We're reversing the substitution, and then we're going to check our answers to make sure that they work out. U is 1/5. And u is 1 over x. So looking at that equation, 1 over x equals 1 over 5. Can you figure out what x should be? Yeah, x should be 5. Similarly, if u equals 1/6, 1 over x equals 1/6, and x equals 6. If we were using the other substitution with the negative exponents, x to the -1 equals 1/5. The -1 exponent, the -1 exponent means take the reciprocal, so x would equal 5. And similarly for 1/6, take the reciprocal, x equals 6. Plugging in them in to make sure that they work, I'm going to need some room over here in my last box. 30 divided by 5 squared minus 1 over 5 minus 1. Does that equal 0? 30 over 25 minus 1/5 minus 1. We have to play a little bit of a game with the denominators here. 30 25ths minus 5 25ths minus 1. Does that equal 0? I'm going to ignore that 1 for now and just work on these two first fractions. I'm allowed to do that in mathematics because I'm just adding and subtracting numbers. So I don't have to put them all together right away. I could just focus on the first two. 30 minus 5 will give me 25. And the reason I do that, you might be able to see right now, 25 over 25 is 1. 1 minus 1 is 0. That works out. Repeating the process for 6. 30 over 6 squared minus 1/6 minus 1. Does that equal 0? 30 over 36 minus 1/6 minus 1. Does that equal 0? I'll scoot this up just a little bit. 30 over 36 minus 6 over 36 minus 1. Does that equal 0? And simplifying here, 30 minus 6 will give me 24. And 24 out of 36 minus 1 is not 0. So 6 does not work. So x equals 5 is my only solution for this last problem in number 5. Talk about a classic mistake. Did you catch mine? Yeah, I made a pretty small one, but it perpetuated a lot. So, since I celebrate mistakes, and I think it's important that we talk about mistakes as a part of learning, I made a pretty simple one that's easy to make. Down here, when I said 1 minus 11 over 60, this should have been negative 10 over 60, which should have been negative 1/6, which means up here, u equals negative 1/6, x equals negative 1/6, so 1 over x equals negative 1/6, so x should be negative 6. Same thing happens down here. Okay, so how does that change my checking? Let's go back over here. In the checking part, the negative 6 squared won't change as far as squaring it. Negative 6 times negative 6 is still positive 36. But here in the middle term, when I have negative 1/6, the two negatives together make this a positive 1/6. And that very much changes our answer. Instead of having 24 there, we have 36. 30 plus 6 is 36. And we do have another solution. Not just x equals 5, but x equals -6 as well. Kudos if you spotted that the first time around. I do apologize that I didn't right away, but again, we all make mistakes. Mistakes are part of learning, and it's a matter of being able to recognize those mistakes and then go back and correct them so that we can learn from them.